All right, here we are at part 2 of inscribed angle notes. We got to right here. Yeah, right here on our last video, and I was running out of space, so I was a little worried and decided to cut short. So let's pick this up. Here's another one of these little theorems. And what these all are, these are all sort of special cases of this is really our main theorem. If an angle is inscribed in a circle, meaning if it's an inscribed angle, then its measure is half the measure of the intercepted arc. We've got one here, and one here. Basically, they're sort of facts that come directly from that, special cases of that fact. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. Now, I made a little special drawing because I really want to show you this one because it's really kind of cool how clear it is if you look at it this way. So let's look at a quadrilateral that's inscribed in a circle. Anytime something's inscribed in a circle, or if a shape is, or excuse me, if a circle is inscribed in the shape, it basically means, well, if a shape is inscribed in a circle, it means that each of the vertices is on the circle. If a circle is inscribed in another shape, it basically means each of the sides of that shape is tangent to the circle. So it means something slightly different. But pretty much it's touching each part one time is one way you could think of it. But so this is a quadrilateral inscribed in a circle. It's got 4 sides. It's not necessarily any sort of special type of quadrilateral. I could use the, you could see the original drawing I used to make it. We could have put these pieces anywhere. I could make it look like this. I could make it look like this. I could make it look like this. As long as we've got 4 sides and 4 points, which is if you have 4 sides, what you're going to have, anywhere on the circle, it's a quadrilateral. And that's the case we're dealing with here. So coming back to here, let's just look at one of these angles first. Let's say I'm looking at this angle. Here's one side of the angle. Here's the other side of the angle. Here's the vertex of the angle. That's an inscribed angle. Okay? Now, let's look at the angle that is opposite from that. Okay? The angle across from that, opposite it, basically means diagonally across from it. If we were talking about quadrilaterals here, remember, consecutive angles mean like this one and this one, or this one and this one. But opposite means this one and this one, or this one and this one. Okay, so let's look at the opposite angle and see what that looks like. Let's go with blue here. So here's the opposite angle. Okay, so those are the 2 angles that are opposite from one another in this quadrilateral, and I could just as easily have used the other 2. But going back to the first one, this sort of pinkish purplish one, that angle intercepts this arc. Okay, now the blue angle intercepts this arc. Well, that means together they intercept the whole circle. So if the pink angle has to be half of the pink arc and the blue angle has to be half of the blue arc, then together the pink angle and the blue angle have to be half of the whole circle. What's half the whole circle? 180. So these 2 across from each other like this have to be have to add up to 180. They have to be supplementary. And that is what this theorem is saying. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. Okay, so we've got B and D are opposite angles. So that means in that picture, and let's see if I can make this a little smaller. It's not working too well, but we'll try, see what we can. If B is 105, then D has to be supplementary to that, so D has to be 75, because 105 and 75 add up to 180. So these 2 that are diagonally across from each other have to add up to 180. And the same goes the other way. these two opposite angles have to add up to 180. So if one of them is 85, the other one has to be 180 minus 85, which is 95. Otherwise, the quadrilateral wouldn't fit in a circle. If the opposite angles aren't supplementary, the quadrilateral is not going to be one that would fit in a circle. Here we have 130 and 170. Okay, so let's look at this. Actually, let's see what we can do with this. Sometimes it's advantageous to have the technology. So let's see what we can do here. I'm really not believing that my son, who I just asked to be quiet, is rustling every package that he possibly could rustle at this point. Thank you, son. Could you rustle that a little louder, please? No comment? Okay, but you could sneeze. That's cool. All right. I'm trying to see how to do this, and I don't know if it's not going to work probably. Because basically what I want to do is I want to take this. Here's how I can do it. I'm going to take this picture right here, this little figure, this quadrilateral, and I'm going to see if I can take it into Geometer Sketchpad. Paste picture. I can! Yay! All right. Okay, so let's move the picture. If it'll let me. Now it won't let me. Yeah, well, let's see. Yes, it will. There we go. Now I got to try and get it back looking about where it did before. That looks about right. The point I'm trying to make here is that there's no way for me to make a circle around this figure where the vertices of the shape go through the circle. Like if I fit these two vertices, here's one right here and right here, then these two don't touch the circle. That's because opposite angles in this quadrilateral are not supplementary. The 130 and the 70 add up to 200 degrees, not 180. So this particular quadrilateral is not going to fit perfectly inside a circle. So that's what that's about. Okay, moving on. Example number 4, use the figure at right to find each angle or arc measure. Okay, the measure of angle A. Well, angle A has one side like this, one side like this. I wasn't kidding about this habit to take your highlighter, your colored pencil, or whatever, and extend the sides of your angle so that you can very clearly see here's the intercepted arc for that angle. So angle A has to be half of 80. So angle A is 40. All right, let's look at angle B. Angle B just so happens to also intercept the same arc. One side of angle B goes through point C, and the other side goes through point D. Just like angle A. If you recall, one side of angle A goes through C, one side of angle A goes through D. Remember, if two angles intercept the same arc, then they're congruent. If they're both going to intercept an 80, then they both have to be half of an 80-degree arc, so they're both 40. All right, now let's look at angle C. Angle C has two sides. One side is here, one side is here. So the intercepted arc for angle C is this arc right here. Okay? Now, I see another angle that also intercepts that same arc. Angle D intercepts the same arc. So if angle D has a measure of 60, then angle C has to have a measure of 60. They both intercept the arc. Another way, the same arc. Another way of thinking about that is, if you look at the purple angle, angle D, if it measures 60, then this arc that it intercepts, arc BA, has to measure 120. Well, the green angle, angle C, also intercepts arc AB. So it has to measure half of 120. Well, that's 60. That's why these two are both the same. So any two angles that intercept the same arc have the same measure. They're congruent. Okay, arc AB, we just said the measure of arc AB is 120. Measure of arc AD. Okay, let's see. Well, it just so happens that we know at this point this part of the circle, 120. We know this next part from B to C is 50. We know the next part from C to D is 80. So basically we know all the arcs together except for arc AD. And we know that a whole circle is how many degrees? So we're going to add up 120 plus 50 plus 80. 120 plus 50 is 170 plus 80 is 250. So the part that remains right here is the only part left to come up to 360. And so here we have 250. 360 minus 250 is 110. So this one measures 110 degrees. And if you're writing this on paper, please use a degree symbol. It's just a little bit harder to do so here. All right, let's see. Find A, B, and C. Well, look at angle A. What kind of angle is angle A? Angle A is actually a central angle because its vertex is at the center of the circle. So here's angle A. Central angles measure the exact same as the arc they intercept. So A is 50. Then we have arc B, angle B. Angle B, it intercepts the same arc as angle A, but it's not a central angle. It's an inscribed angle because look where its vertex is. It's on the circle. So for an inscribed angle, we have angle equals half of arc, meaning it's not going to measure 50, it's going to measure half of that. And it makes sense. Look at the two angles. You can see that one is definitely smaller, that B is definitely smaller than A. So there is B. And finally, I need to get rid of these so you can see this clearly. Notice that circle O, that's what the circle is. The center is O. So this part right here is a diameter. We use diameters a lot in circles because what they do is they cut the circle into two halves, which means I know that everything above there has to add up to 180. So if I know that I have 50 from here to here, I can subtract from 180 and say, well, that means arc C has to equal 180 minus 50, which is 130. And all of these are in degrees, so please make sure you're putting your degree symbol. Okay, so looking at the assignment, I had some people telling me they felt like this was confusing. Hopefully now that we've gone through this a little bit more specifically, you've got some tools you can use here. For instance, if you're asked for this arc, the first thing I want you to do is figure out what angle intercepts it. In this case, it's angle N. Okay, so these two are related. So basically, I'm going to have to figure out what angle N is if I want to figure out this. Or I could figure out maybe, let's see, this angle here, angle L, goes with this arc here. So what if I could find that arc? So pretty much you start out saying, what can I figure out here? Well, if this angle is 53, then the arc intercepted by it is going to be twice that, which is 106. And we just said that everything on one side of a diameter has to add up to 180 degrees. So that's how I can find this angle right here. Let's see if I can squeeze one more in before the video ends. Okay, if this part right here is 92 and everything from D around to F has to add up to 180 because DF is a diameter, then I know that this part right here is going to be 180 minus 92. So that's going to be 88 degrees. Well, here's why this helps me. The angle I'm asked for, and you might have done this first, intercepts that arc. When you highlight that angle, you can see that it intercepts this arc right here, so it's half of that arc.